Another exercise testing the mean but using the critical value approach. We're going to show you how that works. A nutritionist claims that the average sodium content in a certain brand of canned soup is 850 milligrams. You suspect that this claim is not correct, so you are making the claim. How would you state the null in the alternative? So the null hypothesis will be mean equals 850 and the alternative mean is not equal to 850. And who is making the claim? You. So that this is where the claim is in H1. A sample of 16 cans, that's N, shows a mean sodium content of 820, that's X bar, with a sample standard deviation of 40, that's S. Since he gives you a sample standard deviation, then you have to use t-stats, t-test. Test the claim at alpha equal 5% significance level using the critical value method. So we already stated the null in the alternative, and let me show you using StatCrunch how we get the test statistic and the critical value. So we go to stat, t-stat, one sample with summary. Sample mean is 820. Sample standard deviation is 40. Sample size is 16, I believe. We're testing against 850. And the alternative hypothesis is not equal to 850. We need the critical number, and alpha is 0.05, so we're good here. So you can see the whole screen. Let me show you. And we're going to hit compute. Bring it inside here. Okay, so the test statistic, guys, is -3. And the critical number is 2.131. This is a two-tailed test. So we're going to have two rejection regions, one on the right and one on the left. And we're going to use 2.131 for the right and -2.131 for the left. And if the test statistics, which is -3, it falls in the rejection region, then you're gonna reject HO. If it doesn't, you fail to reject HO. But look at the p-value, guys. The p-value is 0.009. This p-value is already less than alpha, which is 5%, so you know what your decision is gonna be. You're gonna reject HO. Whether you use a p-value or a critical value, it's gonna be the same results. So let me show you the critical value method and how we go about doing this. Okay, let me show you the critical value. You draw the T curve, just look like, just a normal curve, 0, 1, 2, -1, -2, and then you put the critical number, which is what? One time is 2.13, another time is -2.13. So -2.13 will be right here, and then you shade to the left of it, and then you put 2.13 and you shade to the right of it. Why we're doing this twice? Because we have two-tail test. Then we bring the test statistic, which is -3, and put it in the number line. You guys agree with me? If we put -3 on the number line, it's going to be right here, which is inside the rejection region. And then in this case, you reject the null hypothesis. So -3 is less than -2.131. And this falls in the left rejection region. We reject the null hypothesis. And if you reject the null hypothesis, guys, and the claim is in H1, you support the claim. So you say there is sufficient evidence at the 5% level of significance to support the claim that the mean sodium content is significantly different from 850. And if you were to use the p-value is 0.009, which is less than alpha, you reject HO, so you're going to get the same results.